How do you know when one of physics' greatest theories is slightly wrong? Well, I'm Rudraj Kulkarni and this is episode 2 of the Nobel Minute. Now, let's spin that wheel. It's 1955. The Nobel Prize in Physics that year was awarded to Willis and Polykarp Kusch for two different experiments that later became important confirmations of quantum electrodynamics or QED. At the time, physicists were extremely confident in Dirac's theory of the electron. Dirac had combined quantum mechanics with Einstein's special relativity, and his theory explained electron spin extremely well. So people thought the hydrogen atom was basically solved. But then, experiments started becoming unbelievably precise. Willis looked very carefully at hydrogen and saw that two energy levels, which were supposed to be identical, actually weren't. There was a slight shift between them. This later became known as the Lamb shift. At the same time, Polykarp Kusch, forgive me if I'm butchering the name, was observing how the electron behaves like a tiny magnet. Rather, how strongly it behaves like a tiny magnet. Dirac's theory predicted an exact value for this, but Kusch found out that the electron's magnetism was actually very slightly stronger than expected. These effects were tiny, like absurdly tiny, but they became very important eventually as physicists realized where this discrepancy was coming from. It came from empty space itself. According to QED, empty space isn't truly empty. Virtual particles constantly appear and disappear, and it is these quantum fluctuations that slightly affect electrons inside atoms. And once those experiments were included, theory and experiment matched beautifully. These experiments became one of the first major successes of quantum electrodynamics, QED. And today, more than 70 years after this Nobel Prize was awarded, QED predictions agree with experimental results to 1 part in a trillion, making it one of the most accurate theories science has ever produced. Also, here's today's fun fact. When Willis first got his result, the experimental discrepancy was so tiny that he thought his experiment had gone wrong. And with that, we conclude the second episode, and I'll see you all tomorrow for the next episode of the Nobel Minute.